So for those of you who weren't around for class, I'm going to go through the practice test, the Unit 4 practice test. Let's look at this first problem on Delta Math. So this is where we are, Delta Math, question 1. Notice that these are the same base. All right, so the same base, which means we can just ignore them and just solve this problem. 5x minus 6 equals 7x minus 2, and just use your algebra skills. Plus 2 on this side, so we get negative 4 equals 2x. And so x equals negative 2. And just put a little negative 2 in there, and that will work for you. All right, let's go on to the second question. And I'm doing this screen right. All right, so here we notice that the base is not the same. All right, these are not the same. And you're trying to make the two bases the same. And so I noticed that 16, if you think of the powers of 2, 2 to the third power, 2 to the fourth power is 16. All right, so this is 8 and 2 squared, and so 2, so 16. So 2 to the fourth equals 16. So I can rewrite this as 2x plus 4 on that side equals, and I'm going to write 2 to the fourth power instead of 16. All right, and now I'm going to use my properties of exponents, which says I should multiply these two. All right, and so I'm going to take 4 times x plus 3, and that's going to be my new exponent. So 4x plus 12. And now that the bases are the same, 2x plus 4, now I can do the same thing I did in the previous. I can take 2x plus 4 equals 4x plus 12. And again, use your algebra skills. And so minus 12 on both sides, minus 12. So this is minus 8 equals, and so we get x equals negative 4. And so we're going to put negative 4 in there, and we'll be all set. And let's move on to question 3. All right, so on all of these, logs and exponentials, all right, we are converting between, come back to screen right here. I think I'll switch to someplace I can switch to blue instead of red. There we go. All right, and so on all of these, we're going to use this idea that log base x of y, we keep the base, so that's b, and then we're going to switch this y over here and make that the power, and equals x. And so that's how we solve all of these. All right, and so we're going to do the same thing over here. So we're going to keep the base. Now notice it says you do not have to solve for x. It will be a little trickier in this one, but we don't have to solve for x. So we're going to do the same thing we did over here. We're going to keep the base. So that's what I say. So keep the base. All right, and the base is 5. All right, and then we're going to switch these other values. All right, so we're going to switch x plus 1 and 2x, and we're going to switch them to the other side. So this becomes our exponent, x plus 1, and this becomes the other side. All right, and so there's our answer. Again, you do not have to solve that. You just need to write in what the answer is. All right. All right. Whoops. Wrong thing. Sorry. There we go. All right. On to question number 4. All right. And we're going to use the same idea that we just talked about. All right. And so in this case, when we start with the exponent, we keep the base. Keep the base. All right. Handwriting is really sloppy. And we turn it into a log. Now, if you check the, I'll show you another way to do this, the way that Delta Math shows it, and it's a perfectly fine way to do that. And then you change the other two. All right, so this would be b of x equals y. And so we're just going to change these other two. And so then you have log base y equals x. All right, and so we're going to do the same thing here. So we're going to keep the base. So this will be log b as we keep the base. And then we're going to switch the other two things. Equals n minus 2. All right, now you're not quite finished here because you have this n minus 2 over on this side. All right, and you just want this in terms of n. All right, and so that means our last step is going to be to add plus 2 on both sides. So our answer is going to be n equals log b of m plus 2. All right, and that's your answer. Convert to log form. All right. Move on to our next question, 5. All right. Let's say indicate where the statement is true or false. The base of the expression log 4 is e. All right, and so that answer is false. So you have to know a couple of things here. First, this is our normal, or this is one way of writing the log form, but also there's two others. And one says log x equals y. All right, and in that one, this is called the common log, and the base is an invisible base, sort of like on one of our invisible numbers. All right, and this is called the common. All right, and there's one more, which is a natural log. This one's called natural, and it has an L in it. So we have ln instead of log, and the n is for natural. And but it's the same thing. This one has a hidden or invisible base, which is e. All right. All right, so now if we come, knowing that, we've come down here and look at our potential answers down here. Log, the base of expression ln4 is e. Yeah, because there is our invisible base, is right here is this e. So that one is true. All right, the base of the common logarithm is 2. Well, no, we said the common log has a base of 10. All right, so that one is false. The domain of the function is 1 to infinity. All right, so this requires us to remember that in our log x form, all right, so this expression or this argument, okay, must be greater than 0. So must be greater than 0. All right, so how do I make this argument? So that means x minus 1 has to be greater than 0. And so in this case, I would say x has to be greater than 1. All right, and that would make my domain starting at 1 and going to infinity. And so this one is true. All right, the expression log x can be any real number. All right, so x can be any real number. Now, I just said up here, or shown up here, that this x must be greater than 0. All right, and so negative numbers, are real numbers, and they can't be used in there. So this any real number is wrong because negative numbers cannot be used. So that one is also false. So you have true, false, and true and false. All right, let's move on to number 6. All right, and we want to condense this logarithm. All right, so in general, our rules are, we have 3 rules about logarithms. I'll just write them really quickly here. One is that, and these go both ways. So if you have log of 2 plus log of x, so when addition turns into multiplication. All right, so we have 2 times x when we condense them. All right, and then we have log of 2x. If we were going in the opposite direction, so if we have log of, then we would expand them to look like this. Right, so this is expand from the small one, and this other one is called condensing because we went from 1 to 2. All right, so that would be the condensed log. All right, and so if you have, so that's one of our rules. Another one of our rules is that if you have log of x minus log of 2, that turns into division. All right, so that turns into division. And whatever has a negative in front of it ends up being in the denominator. All right, so that turns into division. All right, and it goes the same way backwards. All right, and the other way of condensing things is if you have 2 log of x, that turns into log of x squared. All right, so this 2 moves right up here and becomes that. All right. And so when we're condensing this one, we see that we have 2 things we need to do here. One is we need to use this idea. All right, and we're going to move this 2 over here, so we have c squared. All right, and then we're going to use this idea. So where we're going to change add to multiply. All right, and so this becomes multiplying, and so we have c squared. Oops, I forgot this 3. This 3 also goes up here. All right, so we have c2 and k to the 3rd power, and that's going to be inside our parentheses. So in this case, you could eliminate the parentheses if you wanted, because it's very clear what the log is being, what the argument of the log is. But I always put the parentheses in there, never wrong to put parentheses. So anyway, that's our condensing. So there's our 3 properties. So this is our first property of addition to multiplication. So when add, you go to multiply. And here's our second property here. And this is when you have a subtraction, you're going to change that to division. And here you have your property where you have it multiplying, and you're going to change it to an exponent. All right, and these are the same properties that you have for your make that a little smaller. There we go. The same properties that you have for your exponents, the same properties apply to log if you notice that those are the same properties. All right. Okay, so I'm going to discard that and go to number 7. All right, so number 7 is the division. So this is our property, which said that when we're subtracting logs, that they turn, oops, can't have the same value, that'd be 0. All right, that this is going to turn into log of x over 2, or it goes the reverse way. All right, so the first thing we're going to have is we're going to have this 2y. All right, so we're going to have subtract log of 2y. All right, so that's our first one. All right. Notice that it says completely. All right, and so first we need to look at this, the first part of this, which is log 4 of x squared. All right, and we're going to have to move this 2 out in the front. All right, so I'm going to switch to blue here. All right, so that means this is going to look like this: 2 log 4 of x. All right, and then our second one, we're going to notice that this minus log of 2y, that this is multiplying. All right, and so we're going to have to change that into negative. I'm going to put this like this: negative log 2 plus log of 2. Log of y. So that was our rule that said we change multiplication. So this is multiplying, and we change it to addition. All right, but notice that, so now we have this negative sign that we just need to distribute the negative sign. All right, and so we have minus log 2 and minus log 1. And so there's our answer. All right, so when you see this on your test, don't forget to distribute the negative at the end, and don't forget to completely expand the expression. All right, on to number 8. So now we need to solve this. All right, we need to solve this, and we're going to use this idea that log x, this idea that log b of x equals y, that we change that to b of y equals x. All right, so that's the idea that we're going to use here. But first, this expression needs to be by itself. So we can't do this switch of base when we have this 4 here. All right, so the first thing you need to do is subtract 4 from both sides. All right, so now we have equals 3. All right, and so now we have log 2 of x squared minus 2x equals 3. All right, now we can use this idea right up here. So we're going to keep the base. The base is 2, so keep the base. All right, so that's a 2. And then we're going to switch these. Can't write the word switch. Then we're going to switch these. So the 3 goes over here. So that goes that way. And this one goes this way. And this is equal to x squared minus 2x. All right, so now notice that this is a quadratic, and this is an 8, actually, right? And so we're going to subtract 8 from both sides. So we have a 0 equals x squared minus 2x minus 8. Now you can use your very clearly. Minus 2x. So this is a quadratic, so you can solve it by factoring. If you're good at factoring, you can factor this very easily. If you're not good at factoring, use polysolve on your calculator. But since I'm good at factoring, I'm just going to write our two answers, x equals 4 and negative 2. All right, now the next thing we want to do, if you remember, is we want to check your answers. So check answers. Because this value right here, this cannot be negative. All right, and so I'm going to check both my answers. All right, so I have x squared minus 2x, and I'm going to put a 4 in there. So one of the answers is 4. And so that's going to be 16 minus 8 is 8. All right, so that's good. And the second answer is going to be negative 2 squared minus 2 times negative 2. Well, this is 4, and this is also going to be 4, so that's 8. So actually, both those answers work. So x equals negative 4, and x equals 2. Oops, sorry, I have this backwards. So x equals 4, and x equals negative 2. All right, on to our next question. There's a lot of questions in this one, and they warm usually. All right, so all right, so let's look at this now. Notice what we have to do here first is to consolidate these. All right, to condense them. So that's going to be our. Oops, that's going to be our step 1. I'm going to make this a little bigger because I need more room. All right, so the first thing we need to do is condense these. All right, and because this is a negative, all right, that's going to mean that these are going to be divided. So this is going to be a 3 here, and this is going to be a 9x there. And we're going to have a 4 and a log. All right, so that's our condensed version. And I'm going to also point out that we can cancel these two out and just have it say log 4 of 3x equals 0. All right, and now just the same idea. So we're going to have log 4 of 3x equals 0. All right, and although this looks weird because there's a 0, we're going to do the same thing that we've done so far, which is keep the base, which is 4, and we're going to switch these two numbers. 0 equals 3x. Well, 4 to the 0, or any power to the 0, is equal to 1. All right, so this is the same as saying 1 equals 3x. And so we find out that x equals 1/3 by dividing both sides by 3. All right, so we had two steps there, really. One was condense, and then step 2 was switch to between the log and the exponential. Only a few more to go. All right, so we need to fill in the blanks on our amount is equal to the principal. All right, so the principal is the starting value. Make this a little bigger, we need more space. There we go. All right, so we have the starting value. All right, and so that is $7,500. All right, and then we have this end amount. So this is after we apply interest and wait a whole bunch of years, what's our end value going to be? In this case, it says it's 10100 equals 7,500. All right, let's keep going. Now we have 1 plus, and our rate is 6%. All right, so we have 6% here. And it's paid semi-annually, which means twice a year. All right, so semi-annually is twice per year. And that's our number of times, that's our n. So we have n equals 2. And then we're going to have 2 for our other n here, so these 2's match. And there's our time. All right. And that's what we have to figure out is time. All right, so the first thing we're going to have to do is take this 7,500. All right, so now I'm just going to leave that like that. All right, I am though going to convert this 6% over 2 is equal to 0.06 over 2, which is equal to 0.03. I think you could have done that in your head. All right, which means that this is really 1.03. Okay, and 2t. All right, and so now we're just going to do our switch, keep the base and switch. All right, and so notice the base here is 1.03. All right, so we have 1.03, and we're going to have a log of 1.03. All right, now we switch the other two. All right, so this 2t is going that way, and this is going the other way. All right, so over here we have 2t, and over here we're going to have 10100 over 7,500. So you don't actually need to. You can put all of that will go in your calculator. All right, but the last thing we need to do is divide both of those by 2. And so now you find the time is going to be equal to that. And I cannot do that in my head, so I'm going to put this into my calculator. The same one that you use. So it says log base 1.03 and 10100 divided by 7,500. And the whole thing divided by 2. All right, and I put it in my calculator. When I'm looking at my calculator, it looks just like what's on the paper there. And I find out that that is equal to 5.03. And so that the answer to that would be about 5 years. All right, so our question was, how long, right? 12. All right, this is another fill in the blanks. All right, so we have to start with this half-life. All right, so just here. All right, so this half-life is 15 minutes. So that's it. So H is equal to 15. And we have the start and end value. So here's our start value is 770. All right, so that is our start value. And how long will it take to decay, which means to go down to 32. And since this is a half-life, that's why we're using 0.5 is our rate, and the 15 goes here. All right, so now I'm going to rewrite this. It says 32 equals 770 and 0.5 base and t over 15. All right. Now, again, the first thing I have to do is divide both sides by 770 so that this is by itself. And we have 32 over 770 equals 0.5 t over 15. It's easy to get lost on these, but notice I'm following exactly the same steps I did on the other ones. All right, and so now I'm going to keep the base. So keep the base and switch. All right, and run out of space here, so I'm going to write that over here. All right, so we're going to have t over 15 equals log base 0.5 32 over 770. All right, and then notice I'm going to have to multiply that times 15. All right, so this is what I'm putting in my calculator. 15 log 0.5 32 over 770. There we go. And I put that in my calculator. 15 log 0.5 and 32 over 770. And I got 68.83. All right. And so this was in minutes, and it said the nearest tenth of a minute. All right. So that would be my answer, 68.8. And you don't need to put the word minutes in, but it's always helpful to think about what you're doing. All right. So let's look at that. So the first thing we did was find so this was step one, figure out what all there we go. All right, so this was step one. Then we did the same thing. So basically step two, we did our division, and then step three. Here's step three. So we kept our base, which was 0.5, and we switched the exponent, went here in the front, and eventually ended up with the answer 68.8. Oops, wrong thing. All right. Oops, I lost my. There we go. All right, on to number 13. In decibels. All right, so we're going to remember in decibels are measured, are modeled by logarithms. All right, and so we're going to remember that this is a log scale, so we're going to convert it to a log. All right, so let's convert to a log. All right, and I'm just going to pause a minute. I'm trying to think of this quickest way to explain this without re-explaining the whole thing. All right, let's resume recording and solving this. And there is a huge typo here. All right, this should say D equals 10 log. The word log is missing here. There we go. It should say 10 log of P over P0. Okay. All right. And so that would mean that the first step you need to do is divide this by 10, your decibels by 10, and then notice it's a log scale. All right. And so so the first thing we're going to do, notice this is our cat. Our cat is D equals 48, and our dog is D equals 74. And so the first thing we're going to do is divide those by 10. All right, so divide those by 10. And so we get 4.8 and 7.4. All right, and I'm going to go through these steps here, but there's a shortcut here, but we'll talk about that in a minute. All right, and so P0, and so if we and notice this is base 10. All right, so if we make our switch, we're going to have this is base 10 and switch. So 4.8 goes over here, and P over P0 goes over here. All right, and we did the same thing here. Erase this so I have a little more room. All right, so we're going to get 7.4 equals log of P over P0, and that's going to be the same thing. All right, so we're going to end up with P0 equals 10 to the 7.4. All right, so that now notice that since both of these are equal to 10.7.4, we can compare them and we can use our idea of like if we have 2.5 and we have 10 and we say, how many times larger is that? We're saying what number goes in here? How many times do we have to multiply 2.5 times to get 10? And so to solve that, all right, to solve that, we're going to divide both sides by 2.5. And so just in general, when you want to compare how many times larger something is than something else, you divide the two. All right, and so we're going to have 10.4 divided by 4.8. All right, and you can put that in your calculator, but it's going to be 10 to the, we're going to subtract these two. And we can put it in our calculator. Let's just put it in our calculator. All right. So sometimes I get caught up doing things old school. When you have a calculator, you might as well use it. That's what I say, right? And 10 to the 4.8. And hit enter, and we get 398. All right. So a lot. So a dog bark is 398 times louder than a cat's meow. It might seem crazy, but I think I said in class, if you weren't there, if you think about a cat in your neighbor's house, if the cat meows, you can't hear it. But if the dog barks, usually you can. So the dog's bark is much, much louder than a cat's meow. All right. And we're getting down towards the end here, number 14. All right, and what function matches this graph? All right, well, first let's look at a couple of things. Can I get this on the page? There we go. Let's look at a couple of things about this graph before that we might want to recognize right away. All right, one would recognize that this is a decay, right? It's going down. It's going down from left to right. All right. And so decay means that the base is less than 1. Is less than 1. All right. If we look at our answers, well, I kind of obliterated the answers. All right. But we have our base is less than 1. So the other thing to notice about this is that log graphs look like this. All right, so this is a typical log graph. Looks like this. And so this graph does not look like that. All right, this graph looks like one of our exponential graphs. Our exponential graphs were, if it's growth, it looks like this. Right, and so this was our growth. And if it's decay, it looks like this. The one that we have is decay. And if it's a log, it looks like this. All right, so we definitely have a decay graph, not a log graph. All right, and not a growth graph. All right, so here, these first two are for logs, so we definitely know that those aren't right. And then the next one, the base here is 2, and that is greater than 1. And we just observed up here that this was decay, which means the base has to be less than 1. All right, and so that means that one can't work either. And the answer is our last one there, which keeps disappearing on my screen. All right, so when we look at this, you want to look at, is this on the test, is it going to be a growth graph? Is it going to be a decay graph? Or is it going to be a log graph? And then check your answers out accordingly. All right. And now we are on the last question. Number 15. All right, and it says graph the function below, and you must plot the asymptote and any 2 points, all right, on here. And so I have some complicated ways of doing it. They're not complicated to me, but they might be complicated to you. So I'm going to use these 2 ideas that I've used before. All right. So I need 2 points and an asymptote. All right, there we go. All right, so we have these 2 ideas. Whoops. All right, so we have these 2 ideas. One idea, my thing disappeared up here. So I'm going to have to go back because I can't have that disappear because it needs to be on the screen. There we go. All right, so here's an idea. Here's a couple ideas. One is that if you have log base of any number, and the base is any number, and the argument, that's the argument, is 1, that is going to be equal to 0. And if you have the log base and the base matches the argument, that is going to be equal to 1. All right, and so I'm going to use this idea to get my 2 points. All right, so I want log 3 of x plus 2 to equal 0. So that means this has to equal 1. All right. And so for this to equal 1, x has got to be -1. So if x is -1, now it looks like this, log 3 of 1, and that's going to be equal to 0. All right. And so when then I plug a 0 in up here, I have 0 plus 3. So that means when x is -1, y is 3. So there's one of my points. All right, so equals 3. All right, so that's one of my points, which is -1 and 3. All right, and then I'm going to use, all right, so I'm going to erase this, so you can always pause the video and look at it. All right, and then we have this other idea, fundamentals of logs, which says log b of b equals 1. All right, so how do I make log 3 of x plus 2 equal 1? Well, x plus 2 has to equal 3. So when does x plus 2 equal 3? When x equals 1. All right, so erasing this here. We go back to our next thing. So we say when f is 1. All right, so that means this expression is going to be equal to 1, and it's going to be equal to 1 plus 3 or 4. And so there's my second point. I just realized I obliterated my first point. but I think my first point was what, -1 and 3, and my next point is 1, 4. All right, so -1 and 3. I'm going to write those down. Unfortunately, I cannot plot those while I'm using screen write, so I have to get rid of screen write and go back. So I'm going to erase all of this stuff, discard it. All right. And then my 2 points were -1 and 3. All right, so -1 and 3 is right there. And my next point was 1 and 4. All right. There's my 2 points. And then logs have a vertical asymptote. And I'm going to go to screen write again. All right, we're going to remember that. All right, so this cannot be less than 0. Cannot be 0 or negative. 0 or negative. All right, so when is x plus 2 greater than 0? And it's when x is greater than -2. All right, so that this is going to be our asymptote. Of course, it's going to be x is equal to -3, and these are always, so x's are vertical. So we're going to, all right, so we're going to remember this is -2 because again I have to get rid of it. All right, and so we're going to say this is a vertical asymptote, and here's this red line. Notice you move this around and it finishes the graph for you. And so we're going to put that on -2. And so that would be 2 ways of getting 2 points and a vertical line. And submit our answer. All right. And oh, I plotted these in the wrong place. All right. It said I did it wrong. And I plotted these in the wrong place. So I'm not very good at plotting things, apparently. So I have to change those. So I'm looking at this and I don't see any mistakes on it. I know there must be one. Sometimes Delta Math makes me crazy this way. But I found my 2 points, which were -1, 3 and 1, 4. And I'm pretty sure that's -1, 3 right there. And that is 1, 4 right there. And our asymptote is at x equals -2, which is right there. So I don't see what's wrong with this. So I'm just going to hit enter again and bear the consequences of having one wrong according to Delta Math. So we can see. It's wrong. Well, I don't know about you, but it looks like their answer and my answer are identical. -2, 1, 3, 4. Looks pretty much the same to me. So I don't understand why it was marked wrong. Anyway. So, but that concludes that's number 15. And so we're done with that. And so I hope this was helpful in helping you prepare for the test. Pretty long, but you can always pause and move ahead on this video. So I am going to end the recording.